Hi, friends. Today we're going to see how elements are classified and organized on the periodic table. But first, we need to set up our journals to look like this. Remember, key points and vocabulary will go on the left side of the line. So you have line 1, line 2, line 3, same setup as before. The key points and vocabulary will be written in red for this presentation. Now on the right side go our descriptions, definitions, and drawings. These will be on the right-hand side of the line. Notice, guys, it says pages 9 and 10 of our journal. So we are going to be taking quite a few notes. So it's a good idea to set up pages 9 and 10. Go ahead and pause the video to set up your journal. Press play when you're ready to move on. Classifying elements. Now this slide is in blue, so you don't have to write it down, but you do have to know the information. How are elements classified? Each class of elements has unique physical properties. A physical property is a characteristic of a substance that can be observed and measured without changing the identity of the substance. This means we can tell the characteristic just by looking at it. We don't have to add anything to it to see it. Some examples would be color, shine, and texture. Here is a list of the physical properties that scientists and you guys will use to classify elements. The physical properties are brittle. This means they can easily break. Malleable or malleability. This means they can bend or be pounded into sheets without breaking. Think about aluminum foil. Ductile or ductile. They can be made into thin wires. Think about the wires in your chargers, those thin copper wires. Conductivity, the ability to transfer heat or electricity. Metallic luster or metallic, that is shiny and reflective. All right, that means it's got some shine to it. If it's dull, it is not shiny. They might call it earthy, kind of like dirt that's very flat colored, or non-metallic. The zigzag line. This runs right up near the right side of the periodic table, and it divides the periodic table into three main groups. Those are metals, nonmetals, and metalloids. Quick journal checkup, guys. At this point, your notes should look like this. Metals. Metals are solid, ductile. They have a metallic luster. They are malleable. They are good conductors. And metals are to the left of the zigzag line. Look at the example here. All the green parts are considered metals on the periodic table. You've got gold, which is shiny. It's got that metallic luster. And then copper pennies as well, because they start out nice and shiny. Quick journal checkup. The section for metals should look similar to this. Nonmetals. They can be solid, liquid, or gas. They're dull. Remember, non-metallic. They're not shiny. Brittle. They break easily. They are insulators, which means electricity and heat do not flow easily. Nonmetals are to the right of the zigzag line. Notice the blue parts here. And then we have hydrogen as well, which is the only one not on the right-hand side. Some examples are oxygen, the air that we breathe in, or helium, which makes balloons float. Quick journal checkup, guys. The section for nonmetals should look similar to this. Metalloids. Now, metalloids have properties of both metals and nonmetals. They have a metallic luster, so they're shiny, but they can break easily, so they're brittle. They are semiconductors, so they allow some electricity and some heat energy to flow through. Metalloids run right along the zigzag line. Look at the example here. That purple side runs right on the zigzag line. Some examples, guys, are germanium. Germanium is used to make your CDs, your DVDs, and for our gamers, our game discs. Silicone is another example, and you find those in your Chromebooks and your cell phones or computers. The section for metalloids in your journal should look similar to this.